welcome to Proof and Principles. In this session, we will be discussing on the topic Leibniz theorem. In the last session, we discussed about successive differentiation in detail. So now let's talk about Leibniz theorem. But first, we will discuss why Leibniz theorem. Why there is a need to use Leibniz theorem. So let's understand this using an example. Try solving d by dx of x square e power x. If you solve this d by dx of x square e power x, you will get the answer as x square e power x plus 2x e power x. And this answer is obtained using product rule, right? And what does this product rule says us? It's nothing but whenever you have function u into v. So directly apply u dash v plus uv dash. This is what product rule says. Okay. And now if I ask you, try finding out d16 upon dx power 16 for the same function x square e power x. Okay, so now it's a bit lengthy for us to solve it. So here we understand that therefore we require a direct formula. And the requirement is this direct formula should provide us nth order derivative for product of two functions. Okay, for product of two functions. So this is given by theorem which is called as Leibniz theorem. Okay, so this is the entire need for using Leibniz theorem, and therefore we cannot use product rule or successive differentiation for questions like this. Okay, so this was all about why Leibniz theorem. Okay, now let's talk about what is Leibniz theorem. Leibniz theorem provides a formula for finding nth derivative of the product of two functions. Now I think you can link with what we have discussed in the last slide. Okay, a formula to find nth derivative of product of two functions. Okay, without differentiating repeatedly. Now without differentiating repeatedly means here we are not using successive differentiation, because successive differentiation means you have to differentiate on a repetitive basis, right? Okay, now let's discuss about the theorem. If you have y equals to u into v, okay, and u and v both are differentiable functions. Ux vx means u and v both are function of x. So when we have to find out nth derivative of their product, that is u into v, so very first the general form is given by summation r equals 0 to n. N choose r, u power r, v power n minus r. Okay, this is your general form for finding out nth derivative of the product. Now if I say talking about expanded form, if I say I want to find out expanded form, so expanded form is given by this. Now let's talk about the meaning of symbols. Meaning of symbols used here. Very first, this is summation r equals to 0 to n. N choose r. Now you can say this as n choose r, or this is simply called as your binomial coefficient. Okay, this is binomial coefficient. The value for this binomial coefficient is given here, which is n factorial upon r factorial times n minus r factorial. Okay. Now talking about what is u power r. Since I discussed u and v both are differentiable functions here. Okay. U power r is nothing but rth derivative for the function u. Okay, rth derivative of u. Okay, and v power n minus r is nothing but n minus rth derivative of v. Okay, so these are all the meaning of symbols. In this way, you can understand what is general form, and this is the expanded form. Okay, so there is a trick to remember expanded form, and this is very important form as well to solve directly in the questions. Very first, check the number of variables here in the entire expanded form. So there are three variables. One is u, one is n, and one is v. Just see here that u and n both are increasing, whereas v is decreasing throughout the expanded form. Just look into the formula carefully. I have u increased by u, then u1, then u2, so on till un. Okay, so u got increased. Talking about n, initially I had n, then its multiple, n times n minus 1 upon 2 factorial. Then the next multiple would be n times n minus 1 times n minus 2 upon 3 factorial. Okay, so it's increasing in the multiple form. Okay, talking about v, initially I had vn, then it got decreased to vn minus 1, then decreased to vn minus 2, and so on. So this in this way expanded form works. So I think this entire Leibniz theorem is clear to you guys. Now talking about a relation between successive differentiation and Leibniz theorem. So successive differentiation deals with finding higher order derivatives of functions. Let's say if I have to find out nth derivative for sine ax or nth order derivative for e power x. In this way you can find out successive differentiation for functions like these. When I talk about Leibniz theorem, so this theorem extends successive differentiation to the product of two functions, and it provides a direct formula for finding their nth derivative as we discussed. Let's write down the nth order derivative formula again, which was nth derivative of u into v is given by summation r equals to 0 to n choose r, u power r, v power n minus r. Okay, expanded form is given as dn uv equals to, we have also discussed the trick to remember this expanded form, which is uvn plus n u1 v n minus 1 plus n minus 1 upon 2 factorial u2 v n minus 2, so on till unv. Okay, now let's take the cases, special cases. When I have case 1, when I substitute value of n as 1 in this form, so it will be given as duv equals to uv1 plus 1 times u1, v1 minus 1 is v. Okay, and when I put n equals to 1 in this third term, so it will be 0. So this can also be written as uv dash plus u dash v. Okay, which is nothing but your product rule. So whenever you see value of n as 1, so its derivative for u into v will be nothing but product rule. Let's take case 2. So for case 2, when I have n equals 2, okay, let's substitute the value. So I'll be getting d2uv equals to uv2 plus 2 times u1 v2 minus 1, which is v1, plus 2 times 2 minus 1 is 1 upon 2 factorial u2 v2 minus 2 is v0, which is v. So I'll be getting as uv2 plus this 2 factorial and 2 gets cancelled since the value of 2 factorial is 2 itself. So it will be 2 u1 v1 plus u2 v. this can be written as uv double dash plus 2u dash v dash plus u double dash v. Okay, so this is the value for d2uv. Okay, let's take case 3 when I have value of n as 3. So it is written as d3uv. Okay, so it is uv3 plus 3 times u1. v3 minus 1 is v2 plus 3 times 3 minus 1 is 2 upon 3 factorial u2. v3 minus 2 is v1 plus, since it's n equals to 3, I can proceed the same formula. I'll be getting 3 times 3 minus 1 which is 2 and 3 minus 2 is 1 upon 3 factorial. It's 2 factorial here. Okay. Then u3 v n minus 3 which is v0. So I'll be writing v as it is. So this entire stuff, this 2 and 2 factorial get cancelled, and since it's 3 times 2 is 6 and 3 factorial is 6, so this complete can be cancelled. So I'll be getting the final result as uv3 plus 3u1v2 plus 3u2v1 plus u3v, which can be written as uv triple dash plus 3 times u dash v double dash plus 3 times u double dash v dash plus u triple dash v. Cool. So this is the final result for d3uv. Okay. So if you notice the coefficients properly, I have coefficients as 1, 3, 3 and 1. Okay, I'll write it down here. 1, 3, 3, 1. Similarly, I have coefficients here as 1, 2, 1. Okay, and here I have coefficients as 1, 1. So it is some or the other way a Pascal's triangle. Okay, if you notice the coefficients of the results that we have found out, so it's Pascal's triangle, which looks like 1, 1, 1, then 1, 2, 1, and 1, 3, 3, 1. If you proceed further, I'll be getting as 1, 4, 6, 4, 1. Okay. So in this way, Pascal's triangle works. So these are nothing but the coefficients, or simply I can say these are binomial coefficients. Okay, which are n choose r. So these are the value for that. Okay, now let's discuss about the applications of Leibniz theorem, in which we will be discussing few questions. So these are repetitive type of questions. So let's discuss all of them one by one. So let's say you have nth order derivative for the function x square e power x. Try solving this using Leibniz theorem. Okay, when we solve this, we use the basic formula, which is nth order derivative for uv, which is given by uvn plus n u1 vn minus 1 plus n minus 1 upon 2 factorial u2 vn minus 2, so on till unv. Solving this term by term, which is very first uvn. U is, this is u, this is v. So u is x square times vn. So vn is nothing but nth order derivative for the function e power x, which is e power x. Okay. The value for this function is e power x. So I'll be writing e power x. Solving the next term, which is n u1 vn minus 1. So it is given as n times u1, that is first order derivative, which is given by 2x. Vn minus 1. So since Vn is e power x itself, and we know that differentiating e power x continuously will give us e power x only. So I'll be writing again e power x. So simplifying this, I'll be getting 2nx e power x. Okay. Solving the third term, I'll be getting as n times n minus 1 upon 2 factorial u2 vn minus 2. So value for this n minus 1 upon 2 factorial as it is, since value of n is not given to us. u2, that is second order derivative. So I'll be getting 2 times vn minus 2 is again e power x only. So this 2 and this 2 factorial get cancelled. I'll be getting n minus 1 times e power x. Okay. So I got the value for all the three terms. Since it's a polynomial, differentiating it with a finite number will give me 0. So differentiating x square till second order is okay, but if I move forward, I'll be getting all the rest expressions as 0 itself. Now since I have value for all these three terms, I'll write this as dnuv is equals to x square e power x plus 2nx e power x plus n minus 1 e power x. Taking e power x common, I'll be getting x square plus 2nx plus n minus 1. And this is my final result for nth derivative of x square e power x. Let's start next question, which is nth derivative for x square sin x. Let's solve this using Leibniz theorem. Using the same formula of expanded form, I'll be getting value of uvn as x square times sine x plus n pi by 2. Okay, how I got that? So since Vn, which is, this is u, this is v. So Vn, which is dn upon dx power n for the function sin x. We have seen the formula for nth order derivative for sin ax, which was a power n sin ax plus n pi by 2. Since here value of a is 1, substituting value of a as 1, I'll be getting dn upon dx power n for sin x as sin x plus n pi by 2. Okay. So I have substituted the value of Vn as sin x plus n pi by 2. Similarly, the second term would be n u1 Vn minus 1. So value for this will be 2nx sin x plus n minus 1 pi by 2. Just I have substituted the value of n as n minus 1 here. Okay, since I have to find out the nth derivative for Vn minus. I think this is clear. Similarly, for n minus 1 upon 2 factorial u2 Vn minus 2, I'll be getting the value as n times n minus 1 upon 2 factorial. Value of u2 is I'll be getting 2. Vn minus 2 is again sine x plus n minus 2 pi by 2. Okay, this 2 get cancelled. Finally, I'll be getting n into n minus 1 sine x plus n minus 2 pi by 2. Clear? Okay, so I have all the three terms. Let's write down dn for x square sine x is given by first term x square sine x plus n pi by 2 plus the next term, which is 2nx sine x plus n minus 1 pi by 2, and the third term is n times n minus 1 sine x plus n minus 2 pi by 2. So this is my final result for x square sine x nth derivative. Now let's start with the next question, which is nth derivative for x square ln x. Okay, using the same formula again. for u vn, u is x square vn. Okay, so since dn for ln x, that is nth derivative for ln x, is equals to minus 1 power n minus 1 times n minus 1 factorial upon x power n. Okay, this is the value for ln x. But substituting this value will be very lengthy process. Okay, it will be very lengthy. So I'll be directly writing this as dn ln x, that is nth derivative. Okay. Similarly for n u1 vn minus 1, I'll directly write n u1 is 2x times d power n minus 1 for ln x. Cool. Next term, which is n minus 1 upon 2 factorial u2 vn minus 2. I'll write it as n minus 1 upon 2 factorial u2, which is 2, and vn minus 2 is d power n minus 2 ln x. Okay, this 2 get cancelled. It is n minus 1 times dn minus 2 ln x. Okay, so I have all the three terms. I'll be writing the final result as dn x square ln x is equals to x square dn ln x plus 2nx dn minus 1 ln x plus n minus 1 dn minus 2 ln x. This is my final answer. I think this is clear to you guys. Frequently asked questions. Few of them I have already discussed. Very first, nth derivative for x square e power x. This we have discussed. Second, which is nth derivative for x cube e power ax. Third, nth derivative for x square sin x. Fourth, nth derivative for x square cos x. Fifth, x square ln x. Okay, this we have discussed. And for sin x also we have discussed. Try solving these two questions. Okay, so solve these all frequently asked questions. Also, these are all the questions which are homework question, and do let me know the answers for these in the comment section below. Do subscribe to Proof and Principles for more such videos on engineering mathematics as well as engineering physics. Subscribe to the channel. Till then, thank you for watching.